Hello, welcome. This is lesson 10, advanced precalc. We're going to look at some basic applications of functions problems. And so if you look at the given diagram here, for example 1, we have the triangle with the giraffe. And if we make one assumption, and probably wouldn't do this except that it's written as a height, so we're going to call this a vertical height, and we're going to make this a right triangle. And if we do make this a right triangle, then we know that this angle for this triangle and this triangle here, we have similar triangles because we have angle, angle, angle. All right, so if we do have angle, 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 then we can set up a ratio between x and 3.8 and 41 and h. Okay, if we cross multiply and then we solve this out, we get h is equal to 155.8 divided by x. And that would be a function that defines h in terms of x. In example 2, we have this 20-foot ladder that's placed x feet from the base of the wall. So we write the height of the wall, h, the height up the wall, h, as a function of x. So think if you use the Pythagorean theorem here, can you go ahead and see if you can come up with a function for h in terms of x? Try it. Pause the video and write it up and then come back and we'll see if we got it. So if x squared plus h squared equals 20 squared, then h squared equals 400 minus x squared. Then h is equal to the square root of 400 minus x squared. Now, the reason I can't do plus or minus here, if I did minus, I would have a negative square root of 400 minus x squared equals a height. So I would have a negative height, which wouldn't really make any sense. So I need to make sure that I'm creating a model that in the practical application part of the problem, or in the context of what we're dealing with here, makes sense. In this case, the only one that makes sense is 400 minus x squared, the square root of that, with a domain of x is less than 20. So we can't have something bigger than 400, otherwise we'd get a negative number under the square root. So you can't lay a ladder. If you laid it out since it's 20 feet long, if you laid this out as 20, then it would be laying flat on the ground and you wouldn't be going up anywhere. And that's really not the purpose of a ladder. Anyway, on to the next one. Okay, in example 3, we've got two sides of a rectangle that lie on the x and y axis with a vertex at the origin. And an upper vertex is on the line 3x plus 4y equals 24. So the first thing I'm going to do is sort of sketch this situation. Pause the video, try and make a quick sketch, and then I'll pop one up. Okay, so if I sketch this situation, then what I'm going to see is that I've graphed the line 3x plus 4y equals 24, and I've got, this is a rectangle that I would see, and then here's another option for one of the rectangles I might see, and then it could be here to here to here, it could be anywhere. There's just know that you have a vertex going up here, here, and then wherever this is, we don't know. So what we want to do now is see if we can express the area of the rectangle as a function of x, okay? So if you visualize this is x and that's y, then what are we going to do? How are we going to come up with a area of the function, or area of the rectangle as a function of x only? Give it a shot and see what you come up with. Okay, so if I solve for y in terms of x using the 3x plus 4y equals 24, I can easily get that y equals 24 minus 3x over 4. So the area must be modeled by x times the height of y, and y is 24 minus 3x over 4. So this becomes a quadratic 24x minus 3x squared over 4. And when if you go ahead and graph that, you get a parabola with zeros at 0 and 8. Okay, so at x equals 0 and 8. So in practical terms, the domain must be greater than 0 and less than 8, because otherwise if it's 8, you get no area of a rectangle. If it's 0, you get no area of a rectangle. So then we know if the practical domain is between 0 and 8 at the zeros, then the maximum area is going to occur at the axis of symmetry, because this is a parabola that opens down. So just simply find the axis of symmetry, which is between the two zeros, which is our 2 points of symmetry, and I just plug 4 into this quadratic equation here, right? I just plug 4 in here, and I get the max of 12. So if I just plug 4 in, I get a max area of 12, which basically tells me that the maximum area is 12 units squared. There you go, and have a nice day. We'll see you in class. We'll work on the problem set in class, so no stress here.